Welcome everyone to Evernym Webinar on the trust over IP stack. We're going to dive deep into how we're going to achieve global interoperability for self-sovereign identity. And today I'm Drummond Reed. I'm Chief Trust Officer at Evernym, and one of the trustees at the Sovereign Foundation. I work on the standards, verifiable credentials, and DIDs that are at the heart of the trust over IP stack. And so I'll be one of your hosts. And Daniel, over to you.
I'm Daniel Hardman. I'm the chief architect at Evernym, and I also am deeply involved in Hyperledger and Sovereign Foundation things. I'm on the Sovereign Technical Governance Board and so forth.
Excellent. Okay, so we want to start out, every person on this webinar, every person on this planet is affected by COVID-19. So we thank you for joining, and we hope you are staying safe and healthy and sheltering in place. We are clear there's going to be a pre and post COVID world. And we are just one of many companies in working on the digital trust problems in the SSI space. And there's been a collective realization that digital trust, digital credentials are critical for recovering, not just from the pandemic, but also the economic recovery to follow. So we, together with the rest of the SSI community, are coming together on an initiative for helping to design and deliver those interoperable digital credentials. We'll talk about this more at the end, but throughout this presentation, which is going to be about an architectural stack, we're going to use examples, real world examples, some of which we are implementing right now and which we're going to be designing with this community. So that's going to be what we're talking about. We're first just going to do a high-level recap, verifiable credentials and decentralized identifiers, and then governance frameworks, because that's what the stack is based on. And then we'll cover the first two layers of the stack that are about technical trust, and the second two layers about human trust. And then we'll close by talking about the credentials initiative, COVID credentials initiative. So please, if you have questions, enter them in the Q&A for Zoom, and Alex will be helping us collate those and set them up for the second half of the webinar, where we will try and answer every question that we have time for. So we reserved 90 minutes today because this is a big subject, and when we add COVID, it's even bigger. And we hope to finish the presentation in the first half of that and have the entire second half for questions. If you have to drop off at the hour, don't worry, we're recording the whole presentation and you'll be able to watch all of it later. So let's dive into it. We'll start out with a recap of verifiable credentials, decentralized identifiers. And Daniel, I'm going to turn it over to you. If you want to request access, perfect, I will do that. And Daniel, you're driving.
Okay, this is just a quick reminder about some things that we think many of you already know, so I'm going to go fairly fast. Verifiable credentials are the digital equivalent of the things that we carry in our wallet all the time, credit cards, driver's licenses, and so forth. And they are used to establish trust in the same way that their physical equivalent is used to establish trust, but there are some cool superpowers that they have that a physical credential doesn't have. Specifically, they can be cryptographically verified. There was a webinar that was given not too long ago that's an introduction to verifiable credentials as a topic for anybody who would like that background, and you can look it up there. So let's talk for just a minute about some key constructs. This particular diagram is called the kind of colloquially called the trust triangle, and it comes directly from the concepts that are laid out in the verifiable credential data model standard. There are three roles in that standard that are particularly important to the mental model. One is the issuer that creates credentials, one is the holder that holds them and then turns around and proves things, and one is the verifier. And in this particular version of the diagram, we have an issuer as an institution, a holder as a person, a verifier as an IoT device, but any one of those roles could be played by any one of those kinds of entities. But credentials are generated by an issuer and sent to the holder. The holder then turns around and presents proof. And in the middle at the bottom of the triangle is this thing called the verifiable data registry, which is where blockchain comes into the problem domain. I see that somebody has raised their hand. I'm not tracking that very well. Could Alex, could you maybe chat offline and interrupt me if I need to, if I need to stop?
Yes, I will. Yep.
Okay. So anyway, this is kind of at a very high level conceptually how verifiable credentials do useful stuff. But let's dive into the details a little bit more and talk about what actually happens underneath when we're using them in a specific situation. So this is a view of the same triangle now. And we have the blockchain at the bottom. That's the same thing as that verifiable data registry that was on the previous slide. And what happens at the beginning is that an issuer writes to the blockchain their public key. That's going to be important later because when the verifier is checking the correctness of a credential, they're going to use the blockchain to do it. So the issuer starts by writing their public key to the blockchain. And then from there, they create a verifiable credential, which is a digital file, and it needs to go through a special kind of digital signature formalism. So once the verifiable credential has been signed, it's given to the holder, and then the holder uses it to generate proof. And the verifier evaluates that proof by reading some information about the public key from the blockchain. And they can then tell whether the signatures are legitimate. And that is the process that we call verifying. Now, the important thing to know about this is that there is no integration needed between verifiers and issuers. And that is profound, and it's different from the way credentials have worked for hundreds of years. Verifiers don't have to coordinate with issuers at all. They have to know that a particular issuer is one that they consider trustworthy, but the issuers don't have to know that the verifiers even exist. There doesn't have to be any kind of system integration work between them. Verifiers interact only with holders. That's why there's a big arrow between holders and verifiers. And the dotted line represents a posture of trust between the verifier and the issuer, but not any kind of calls or system integration work. And that is huge in terms of value. So what I would like to do now is emphasize how connectivity works in this world. The holder and the issuer have to have DIDs that allow them to build a secure pipe so that they can have strong communication guarantees between them. You can think of this pipe as being like a private VPN, although it is very different in terms of how it's actually built underneath. But the holder and the issuer exchange pairwise DIDs and then use that to create that pipe. And then on the other side, there is a pipe between the holder and the verifier. And by the way, these pipes don't have to exist at the same time or be used simultaneously. So the holder and the issuer communicate whenever they want to, and the holder and the verifier communicate whenever they want to. Those strong pipes are the things that provide the basis for both security and privacy in this ecosystem. Now, there was a version of this slide that I thought was in the deck, but it doesn't seem to be showing up. That was about credentials in a COVID-19 scenario, and I'd like to talk about that briefly. Did we somehow miss that one? Let me see if, oh, here we go. Yeah, I just went past it too fast. So in the context of COVID-19 credentials, this trust triangle manifests very obviously. You could have the hospital be the issuer, you could have the patient be a holder, and you could have an employer be a verifier. In that case, the credential would be something saying the patient has recovered and is no longer shedding viruses that can infect anybody and has antibodies in their system, therefore let them come back to work. And so an employer can solve a COVID-19 problem with a patient and with the hospital without the employer calling up the hospital. And this is just one of dozens of use cases that apply to COVID-19. We're going to talk about some more of them as we make our way through this deck. I think at this point, the thing I'd like to say is that all of the trust that gets built during this these series of interactions rests upon assumptions that need to be made explicit in something that we call a governance framework. And so that's something that Drummond ought to talk about. Drummond, over to you.
Thank you, Daniel. So in the world of digital verifiable credentials, governance frameworks actually do play a very special role. And one of the most obvious ways is because there's no direct integration needed between verifiers and issuers, as we talked, how do verifiers actually know all the issuers? Take the example Daniel just provided. How does an employer know what hospitals and testing labs might be valid issuers of a COVID-19 test credential or vaccination credential? And the answer to that is governance frameworks. So the easiest way to understand them that I've found to explain is to point out it's a second trust triangle. We show it here, we call it the governance trust triangle. And what you have is some governance authority that, again, is basically aggregating a set of issuers into a community. And the verifier simply needs to know, oh, I'm going to trust that governance authority because it publishes a governance framework, which is human readable set of documents, typically not only just on the web, but they actually, those documents and that governance authority also have DIDs on a blockchain so that it can be very, very clear and cryptographically provable. That's the author of this governance framework. And then a governance authority can authorize the set of issuers. In this case, for instance, this governance authority, well, I think we have an example right here. Actually, I'm going to go through the best known example that we could use right now of all of this is how payment networks work today, right? The governance authority is the payment network. Visa, MasterCard, Discover, they all work this way. And then you turn around and they are authorizing the issuers of credit cards. And those credit cards are called, those people are called card holders. And they can now use that as a credential to go to any verifier merchant to authorize payment. So that's the model. And what we're doing with verifiable credentials and governance frameworks is we're generalizing that model so that any community of any size, be it a global payment network, a government, a university or a consortium of universities, all the way down to a city or a neighborhood can turn around and institute a governance framework so that the credentials that a set of issuers are issuing can be trusted by all the verifiers that can read, inspect the governance framework, look at how the governance authority is doing it, all the policies that are followed, and know what they can trust on those credentials. Now, if we go to the example that Daniel was just giving, again, to ground this in COVID-19, here the obvious governance authority that we're reading about every day is a CDC. And as we talk about the initiative at the end of this call, one of the things we want to get to is a governance framework that allows CDC and others potentially, they maybe cooperate with others, to turn around and say who are authorized issuers of COVID-19 credentials, testing facilities, hospitals, other trusted providers of that information. That's who will be able to issue those credentials. And we'll take the example that's already being implemented out there, which is doctors need credentials, doctors, nurses, other healthcare professionals, so that they can turn around and service the many different hospitals now that they need to move between to literally follow the virus, follow the cases. And it's in the news. I just saw it this morning in the New York Times about doctors having to cross borders, state borders in the US or borders in the EU to go help with this, and the credentials are not recognized in those other places. So a proper governance framework will allow that kind of portability. All right, when we use that term governance framework, yes, we're talking about a set of documents I'm not going to go into any detail on these. I just want to say this is an overall anatomy of what that looks like. That's been developed in 3 years worth of work at the Sovereign Foundation Governance Framework Working Group that I co-chair, but is now being submitted to be part of the Trust over IP stack as a general model for governance frameworks that we'll be talking about here in a minute. But this is human readable governance frameworks, and one of the most powerful things about governance and blockchain and digital agents is that you can also have machine readable. Dan, do you want to talk to this?
Yeah, I just wanted to make you aware, some of you who have been in the space for a while have been aware of governance frameworks as a general topic and have known a lot of what Drummond might have just covered, but this is brand new. In Hyperledger Aries, we just had an RFC proposed that specifically deals with how you could turn a governance framework that's, that consists of human readable documents vetted by lawyers and subject domain experts and so forth into code readable stuff that can be automated and produce algorithmic governance. And so I wanted to invite you to go learn more about that if you'd like. It's Aries RFC 0430. And the two screenshots here, one is just a little screenshot of the beginning of the RFC. The other is a screenshot of a JSON file that contains the metadata of a trust or a governance framework for COVID-19. And this is the kind of JSON that would be consumed by code that would tell software who are the issuers I should trust if I'm using this governance framework, what kind of rules apply, and so forth.
Exactly. We could do an entire webinar on machine readable governance frameworks in this RFC, so highly recommended. So again, the key takeaway of this whole thing is that when we talk about digital credentials, anything other than single-use credentials from a single issuer, the credential is only one half of the coin. The governance framework is the other half of the coin. And I want you to bear this in mind as we go in and explain that's a core principle of the Trust over IP stack. And it was developed and is growing in maturity. We'll talk about where it's going here at the conclusion of the call on how we standardize SSI so we get the universal operability, for example, that we need for COVID-19 credentials. And that's why we've been developing the Trust over IP stack. First, let me explain that the term itself was coined by John Jordan, who's the Executive Director of Emerging Digital Initiatives in the province of British Columbia in Canada. Many people probably already know Canada as a country, and BC Gov in particular, has been a leader in digital identity for 2 decades now. John and his team have become major contributors, not just to the standards, but also to the Hyperledger Indy and Ursa and Aries projects that are where we're implementing much of this. And what he realized was this stack that we developed, which we originally called the SSI stack, was actually much broader than SSI. It covered, it was a blueprint, an architecture for trust at internet scale, trust at distance. And that it had an analogy, just as we learned once we had TCP/IP, the basic protocol stack that enabled the internet, and then we started layering protocols over that were things we did offline that we can now do offline. The best known being voice over IP, right? And so he said, oh, well, what we want to do here is trust over IP, and that was the origin of the term. Many sophisticated architects turn around and go, well, this isn't limited to just IP-based communications, and you're right, but still, it's an easy way to capture that, and it condenses down to a nice acronym, ToIP, that you'll see in a lot of places. So, and by the way, everything we're talking about here was published last, I think, late August, is a Hyperledger Aries RFC. All you have to do to find it is search Hyperledger Aries and then put Trust over IP, and you'll get that RFC. So the stack, the first stack, we're going to build the stack for you to explain it piece by piece, but the most important thing to understand at the outset is it's a dual stack unlike most standards that just address technology, which is the left side here, you're going to see how this stack also addresses the other side of the coin, governance. And it does so all the way up and down the stack. So Daniel's going to be covering the left side, and I'll cover the right side. And Daniel, you want to start out with layer 1?
You bet. So at the bottom, we need the ability to create DIDs specifically for issuers, but also for other parties who want to do useful things in the ecosystem. And creating those DIDs, of course, requires that we have some source of truth that we interact with, and that we have an agreed upon method for determining the state of a DID, what its keys and endpoints are. And so technical trust at this layer 1 is creating one or more public utilities that the world can use to generate DIDs and do work with them. When I say do work, I mean build those secure pipes that we talked about before, which comes in another layer in a minute, and doing the registration and update of the DID metadata.
So that is what I call the anchor layer, right? And in fact, there is an initiative coming forward for the first one we can point out as an example there is the Sovereign Network that has been designed at the outset to be a public permissioned global utility for self-sovereign identity. So it's explicitly designed for that. So there is another network like that called VerisOne that's also of that type. But it's important to point out, not only can there be Sovereign's Hyperledger Indy based, there are other Hyperledger Indy based networks coming as utilities on layer 1. And any other blockchain that supports a DID method that will support the higher layers. And part of the stack is it will become very clear what are the technical requirements for doing that can be a layer 1 utility. And that does include, certainly Ethereum has that capability. If Bitcoin, I think in theory, can support it. There are DID methods for it, so we will see. But certainly any modern blockchain with reasonable flexibility should be able to support that. Now that takes us, what's the other half there? It's what we call utility governance frameworks. And if you're running a public permissioned chain of Hyperledger Indy, then it's designed, you explicitly have a set of roles, the 3 roles defined in the Indy code. A steward is actually a trusted institution that runs a node. The transaction authors are the ones who are writing transactions, and there's a role explicitly for permissioning called transaction endorser. So you will see that if you go to the Sovereign Governance Framework, just literally SOVRIN governance framework, search that, you'll come to the homepage. You will see an entire 3 years worth of work on creating a governance framework for governing that kind of utility. There are going to be many other ones. There are, in Europe, there are 2 initiatives, FINDI and LISSI, LISSI. FINDI is the Finnish Indy initiative, and LISSI is starting in Germany, but is EU-wide. And they're, again, Hyperledger Indy networks that will follow this model. But even Ethereum networks or Bitcoin, there is governance. It's not formal, but it's algorithmic governance that in some cases it moves all the way to the blockchain itself at this layer.
Well, there's also governance of how the code is written. So you could say that there's algorithmic governance, but there's something behind that, which is how the coders contribute the code that runs the algorithms.
Exactly. So together, this is the base layer, the foundational layer, the strong roots of trust that are needed for the DIDs, as you'll see as we go up the stack. So Daniel, over to you for layer 2.
Yeah, so once you have the ability to determine what the identifier for another entity in the ecosystem is, you can build the secure pipes that I was talking about earlier in the presentation. These pipes are based on mutual authentication that's done the same way on both sides, where each party holds a DID, and then each party can prove that the other party is interacting with them because the communication is encrypted using keys associated with that DID. And we call these things mostly the focus here is on what we call peer DIDs. These are DIDs that are intended for these pairwise communications more than they're intended for public operation. Public DIDs also surface a little bit at this layer, but I'm going to focus more on the peer DID side. What the peer DIDs connect on either side of this secure pipe is software that we call an agent, and the agent has the capability of storing, sensitive data in a wallet. And so either side of this connection then is backed by an agent that is able to send secure messages back and forth and prove that the other party is who they think they are. And this general capability is what we call DID communication, or DIDCOM for short. You can think of DID communication as being like TLS. It has many things in common with TLS, but DIDCOM is actually transport agnostic. So you can use it over HTTP, and you can use it over TLS if you want, but you could also use it over email. You could use it over Bluetooth and so forth. And as you might imagine, how you use DIDCOM raises some interesting governance questions. So ping pong back to you, Drummond.
There you go. So at this level, we have a different type of governance framework, which we call provider governance framework. And it is all about how do the participants in an ecosystem trust the agents and wallets and what we call agencies. So we're showing here two mobile devices at the edge and a connection that might be formed directly. I mean, literally Bluetooth or one phone scanning a QR code in the other, and instantly you have a connection without any intermediary. Every time I present on the stack on that, I'm pointing out this is not going through LinkedIn. It's not going through any social network. It's not even going through some central directory service. It is a direct connection between your two wallets and agents. It's cryptographically formed, and the DIDs, those peer DIDs, will last forever. The only reason that connection ever needs to break is if one of or both of the parties no longer want it. So it's a very powerful new form of secure channel. And here we're showing, again, edge devices, but these connections can exist any place. Your agent can be local, it can be in the cloud, and you can have a set of these devices that locally that are commuting via cloud agents just to route messages. So that's a host of cloud-based agents. The term we use is agency. And with agencies, they're not seeing any of the data. It's all encrypted, but they might be storing encrypted backups. So the bottom line is there's potentially metadata or privacy issues around running agencies. So what a provider governance framework does is set security, privacy, and data protection standards for producers of hardware, software, and agents and agency operators, so that both consumers and businesses and governments can be confident in recommending providers that meet those certification standards. So on up to layer 3 now, Daniel.
So at layer 3, this is where I find a lot of fascinating things happening. This is where you solve what I'll call business problems, application level problems. And specifically, we build the kind of trust that we need very obviously in a post-COVID-19 world, where what we're trying to do is help a human being be trusted or trust some other institution or human being or whatever. And we do this by running protocols on top of the DIDCOM secure pipes. So an example of that protocol is the protocol that you use to issue a verifiable credential. And another example of such a protocol is the protocol you use to prove something to a verifier. And there could be variations and enhancements of those protocols. There could be one where Alice introduces Bob to her friend Carol. Human introductions are a protocol. There could be one where an employee at an organization shows up and clocks in and proves that they don't have a COVID virus. All of those kinds of things that are kind of based on the foundation of secure communication at layer 2, plus having verifiable credentials and being able to prove things with them at layer 3 are what comes into play at this data exchange protocols layer.
Absolutely. Now, when we showed earlier the two sides of the coin, this is where it's going to be most explicit. As I said before, if an issuer is issuing a credential that they really are intended to be the only verifier of, right? When you think about any username or password that you have at any website, that's a credential, but it only works in one place. And in fact, you're explicitly exhorted for best privacy security practices not to reuse that credential anywhere else, right? Which is part of the reason we have such, usernames and passwords are so painful. Well, the beauty of verifiable credentials is they're like the credentials in your wallet. They're designed to be used anywhere they're useful. And so we can literally invert it and get the credentials that will be very widely accepted. And at the same time, stronger security and better privacy by far because of the architecture we've been talking about here, where you're not being tracked and traced by virtue of that information. So this is where, again, credentials shared with a wider audience, the ability of a verifier to make a trust decision about a credential comes down to what's the governance framework it's issued under. And so at this level, governance authorities will create governance frameworks that define a different set of rules, like what we talked about earlier. How do you know who the authoritative issuers of a credential are? There's several solutions for that. One of them is what's called a credential registry. And it doesn't have to be a single centralized service. The governance authority can literally issue credentials to all the authoritative issuers and to multiple registries around the internet that are cryptographically verifying that is a credential from the governance authority and maintaining publicly referenceable human and machine readable registries of those authoritative issuers. And you're also going to have credentials here that go the dimension, like many of the credentials in your wallet. Are they insured, right? How much trust can a verifier put if the issuer makes a mistake? Is there a financial compensation that's available via insurance? So this is a whole new market for dealing with risk issues that exist everywhere in modern business today, and digital business and supply chains. And so we think there are, when you're thinking, yeah, we might have at layer 1, who knows, couple dozen utility governance frameworks. At layer 2, we may end up with only a handful of provider governance frameworks. They'll be very broad. But at layer 3, we can end up with thousands, tens of thousands of credential governance frameworks. Again, each one addressing the needs of a specific community. And of course, great example, COVID-19 credentials. There we actually want, ideally, one governance framework that is very widely adopted for a set of credentials that we want to interoperate everywhere. But you can already see that's a fairly narrow usage of an extremely valuable credential. All right, let's pop up and the last layer. Over to you, Daniel.
Yeah, so at the highest level, on the technology side, you have, I'll call them enclaves or ecosystems or communities that grow up that are all doing things that are interoperable, and not just interoperable theoretically, but that are used every day in interoperable ways. So sticking with the COVID-19 situation, you have a nurse who shows up at a hospital and uses credentials there at that hospital. And then maybe she has to go to a different hospital later in a shift or when she volunteers somewhere else. And so now multiple places are accepting the same kinds of credentials, and she's maybe doing different things. And then maybe she becomes a patient and needs to document certain things. And maybe she also needs to show up at some kind of a public refugee camp and provide some service. And the set of entities that interact together around common credentials and shared trust frameworks and shared technology you would think of as an ecosystem. And you know, you have the governor of New York, Andrew Cuomo, recently said, hey, if there's any medical professionals in other parts of the country that are willing to come and volunteer to help us here in New York, please get here. We want your help. And really, that bid for help is a bid to grow an ecosystem. And from a technology point of view, if everybody shows up, but none of them are using things that talk to each other, we will have a big mess on our hands. So the creation of those ecosystems is vital. There will never just be one of them. There are reasons why certain ecosystems have different regulatory requirements and different health requirements and so forth. But we want those ecosystems to be healthy, to have high integrity within their boundaries, and we want to understand what it takes to move across those boundaries. And that brings us back to governance again.
It certainly does. And at this highest level, we have what are now being called ecosystem governance frameworks. And they are, as you would expect, the broadest, but in some ways they may actually be the most useful because they establish the broadest circles of trust, ecosystems of trust, potentially for entire industry. Some of them may even be global. An example from our the real world today is our passport system is an international set of credentials taken decades to evolve and has regulatory support in governments all over the world. That is certainly an ecosystem governance framework for the travel area. Some of the earliest interest in verifiable digital credentials was, of course, from the travel industry because it's so critical to cutting down time, cost, hassle at borders and increasing economic flow. So they have gotten involved early, and that's a great example of an ecosystem governance framework that might be global in scope, okay? But every one of the examples we've talked about here, from something fairly narrow to like one set of COVID-19 credentials to something that broad, we are seeing dozens of examples of ecosystems that are saying, okay, now that I see this stack, I want to set up a coordinated set of credentials from a coordinated set, and support multiple credential governance frameworks, whatever provider governance frameworks meet the needs of that ecosystem, and the utility governance frameworks. Most ecosystems, I think, will not be defining these lower levels. They'll simply be saying, there's certain utilities, their governance frameworks and their operations meet our requirements, and they will be whitelisted. That's why the first role we show up there is member directory, right? It's very simple, very similar to the credential registry at this level, only it's literally a white list of DIDs of all the members of that ecosystem, and those members can be other governance authorities, top to bottom. They all have DIDs, they all have governance frameworks. So building a web of trust, now there's a real both machine and human readable way to build it and to navigate it and to make trust decisions of any kind. Now, when you get up to this scale, there are two other roles that I want to point out can actually exist in governance frameworks at any level, and they are two roles that are very common in what's called trust assurance, which is going and measuring and certifying the participants in a governance framework. That's the job of auditors. There's a whole consortium worldwide of auditors for the digital certificates for TLS SSL certificates that you use to get the lock in your browser. But those auditors can audit any kind of digital infrastructure, and they're very interested in auditing this. If you get to enough scale, you actually get to a role called an auditor accreditor, which will manage authorizing auditors all around the world to audit for a particular governance framework. So a few other examples before we leave this. There is a huge amount, of course, credentials are one of the essential products of the education industry, to put it that way. So there are several very large scale initiatives on digital credentials for higher education. The Digital Credentials Consortium is one of them, and Learning Economy is driving another one called the Internet of Education. Those are perfect examples of ecosystem governance frameworks that can be quite broad, that can bring together many different credential governance frameworks for different kinds of educational credentials, and then specify, for students and faculty and universities, what are acceptable provider governance frameworks, what are acceptable utility, and put it all together into an ecosystem of trust that can really build the confidence of all the participants that they're not running into so many of the security and privacy and data protection issues we have on the internet today. All right, deep breath, Daniel. We have built the stack, and we're building a nice stack of questions here too. So before we get over to those, let's just quickly wrap up. I hope it's been clear that we believe that SSI, the standards by themselves are not enough. They need to be composed into a stack that we've just presented here that is globally resolvable, interoperable, and trustworthy, and decentralized. There is no central authority involved. You could say every governance authority we've talked about is a central authority, and everyone can be one. So, you are literally the center of your web of trust, no matter who you are, a person, a company or organization, a consortia, a government, right? And so the promise of trust over IP is to take us to an interoperable trust layer for the internet, just like the TCP/IP stack took us to an interoperable internet. And again, it's not a coincidence. Again, thank John Jordan for that name. So we said we would, again, make sure it's clear that we're not just talking about COVID-19. We are one of many companies and participants in the SSI community that are doing something about it. And the address here is at the bottom of the page. Again, we are helping organize and bring together, along with other companies and leaders in this space, a community-driven project for, and this, I'll be very specific, a credential governance framework and the associated definitions and technology that are necessary for a family of COVID-19 credentials. Daniel, you've got 4 bullet points here. Do you want to talk to those?
Well, those are 4 specific types of credentials that have been identified as being very high value and having obvious application to many different stakeholders. And so they are ones that are under active discussion. There is schema work for each of these. So if you want to see what the schemas are like, reach out to us. We can tell you more about that. This is not an exhaustive list. There are dozens of other angles on this as well. These are just 4 really obvious ones. One that's not on here, for example, well, actually, the first one might or might not, depending on how you interpret it. But, the German government has recently announced an intention to qualify people to move around based on presence of antibodies in their blood. So maybe that would be an example of bullet 1.
Excellent. So again, what's actionable about this is if you or your organization or others that have been talking about the subject and want to get involved, we have a page where you can sign up. And we do a lot of work at Evernym on collaboration on the standards, collaboration on projects that involve an ecosystem, right? Multiple issuers and verifiers and populations of any scale for holders. So we want to see this done well as quickly as we can. It's a global health emergency. And in an interoperable way where everyone can participate.